design is seen as a necessary evil. It's not seen as a tool to innovate. It's not seen as a tool to maybe access new markets or to make changes. You have to have the mentality that design is a tool for change, innovation and profit. Because the seed-to-all cost starts with design. Get the design right. And these 3D digital tools help us to do that. My last one of charting type stuff. But by being quick, by developing products quickly, hence rapid manufacturing, rapid tooling, etc., we do it because we want to get into the marketplace as quickly as possible. So if we want to look at our level of sales here versus a time scale, if we can get into the market sooner, there's lots of benefits from that. We can probably charge a premium price, we'll probably be the market leader, and we'll probably enjoy a much lengthier period of sales than our competitors will. So speed is important. Again, I've got a few slides here that illustrate what people are doing with this technology. This chair is called One Shot. It's produced by MGX Materialise in Belgium. And I just want to show here that how it folds up, and therefore it's got numerous mechanisms up here, but it's produced essentially or virtually in one piece, in one hit. As a consequence, it's been it's in the Modern Museum of Modern Art, it's in the Design Museum as an illustration of how good these technologies can be, potentially. This is by a design group in Italy, which I quite like, where they're using digital technology again to produce objects in a slightly different way. So here, as a piece of ceramic ware, you imagine trying to tool up for that. You imagine trying to produce a tool for that. That's difficult. Here, they're basically saying, oh, I can change the colour. I can go on the screen, it's going to be white, it's going to be black, I can do that. I really quite like the birdhouse here. The idea is that you can hear the baby chicks inside tweeting, but again, it's produced with very minimum and no tooling. So it's the ashtray with the ventricles of the heart coming off it. They're obviously having some fun with those. Again, the freedom of creation stools, the fruit bowls, jewellery, and other vases. Again, when you look at all the structure that's involved here, it perfectly suits this form of growing products, which is the way that we're moving. But equally, I said that we try to use a range of tools. We've got the 3D printing, we've got the computer modelling tools, but equally we use basic scanners here. And you'll see a scanner outside, except this is a different version of the scanner here. It's a laser-based scanner, where we can scan busts, where we're doing a lot of small historic objects, where we can scan them. This is what the scan data looks like within the computer, this wire mesh here, and we can rebuild them at scale. And we can scale it up, scale it down, we can mirror it, we can fix it, we can mend it. We've got so much flexibility in the computing environment to manipulate an object. I brought this particular sample with me out on the desk, but we were asked if we could rebuild this old Victorian tile here. It's in a very poor state of repair. So we took a photograph of it and we scanned it. That's what the scan looks like. Got no colour to it yet. That's the back of it. It's quite a simple component, a simple item. That's when we've rebuilt it digitally. That's the back of it. And that is a photograph of what we produced that came off the 3D printer. We took the photograph, we wrapped it onto the three-dimensional mesh, and then it's a case of file print. Nearly. We then give it to our conservators, who then can add glazes to it to make it look as far as possible undistinguishable to the naked eye from about 2 or 3 metres. So we can use it in the conservation industry because we do a lot with conservation work. They wanted to know whether I could do picture frames. So they just gave me a corner piece of a picture frame, and yes, we were able to scan that, but we were also able to rebuild this particular picture frame into one piece. So this was just the example that I gave them to basically say, yes, if you give me a picture frame, it's a very complex or organic structure, but we can rebuild it. and we can do some slightly more funky things with it. We can then print it out in translucent materials and make it as a range of lights. So there's no picture in the middle, but they're just sort of desktop lights. And that was the idea. We have laser cutting machines. They're very popular. They're quite commonplace now, particularly in schools, colleges, and industries. But as a means to cut, as a means to use it through digital technologies, it's great. We can use Illustrator, we can use Corel Draw. Potentially, we can use any program that talks to a printer to create something off a laser cutting machine. So in this case, we produce some invitations for a graphic artist, and it allows us to produce lots of. Our architects love it for making architectural models, so it's quite a versatile tool. But I'm not going to dwell on that too much. And I think that's probably about it for me. It's just a brief summary, an overview that looks at a range of three-dimensional computer-based tools, CAD modelling, 2D-based tools, to either talk to a printer or to either receive information from a scanner so that we can do something with it and produce something. But hopefully we can see some of the benefits as well. Okay?
We've got a little bit of time for questions, if you don't mind taking them. I'm not quite sure. Does anybody have any questions about all that? There's probably quite a few, I suspect. Basically, about what is the magic that does this? But yes, the gentleman's above.
Yeah, I'd be interested in knowing more about the kind of companies you work with, commercial companies, in your with universities.
From my experience with the plastic-based rapid prototyping, we tend to do and have done quite a few enclosures. So people are producing widgets or bits and pieces and they need an enclosure for it. And it's traditionally quite expensive to go and get something made or fabricated, and certainly if you want to go down the tooling route. So this process is ideally suited for us to say, okay, well what's your application, how are you using it? So we've produced enclosures for cameras that have been installed onto roller coasters. We've produced enclosures for security cameras for bespoke applications. We've produced a lot of sort of plastic-based consumer type items. We've done stuff for little rulers for home base for bricklayers. More recently, we've produced for some enclosures for the medical industry to help with processing pills and to get pills out of packets. I don't tend to show some of that stuff because I didn't sign NDAs.
Supposing somebody had an idea for a product that they thought was an innovation and they thought there was a market for it, would they just approach Lincoln University directly? How does that work?
We've had many individuals approach us, inventors or call them what you will. I tend to focus on not necessarily the product or the product idea. I tend to focus on what's the business opportunity, what's the business idea. So I might be given a widget that does something and it's great, but I'm looking at it thinking, well, in its current form, it's too expensive for the market that it could go into. We need to reduce the cost on it. It's a different problem to solve. I'm interested in the business problem rather than the product design problem. That comes next. What's the market? Who's the market? What are they prepared to pay? What's the need? Where's that need? How are you going to get to that need? That kind of thing. That's what I'd be looking for.
I should just add to that potentially this project could buy a piece of equipment like a 3D printer. So, it's not unimaginable that those resources might be there as part of the investment that the Lincoln County Council makes.
What, my house?
No, not at your house. Sadly not.
More likely to be mine.
The only thing I would say about it is that the problem that everybody knows, why aren't 3D printers so much more popular? Hewlett-Packard are into 3D printing and their support by the American companies that make 3D printers. We've got British universities looking at 3D printers you can build yourself. Why are they more relevant? I think one of the simple answers to those is that if we were to go down a 3D printer and we stand it here, there's probably 4 buttons on the front of it. The mechanics inside of it are not fantastically complicated. What's made 3D printing possible is computing power and software. So for me to produce an object on there, for me to digitally reconstruct an object, you've got to be proficient with 3D modelling tools. And at the moment, they're notoriously difficult. They've come out of the engineering industries, the high-value manufacturing industries, and they use a language which is quite alien to many people. You've got to make sure that your tangent curves fit your class A1 curve and the kind of degree of curvature that you've got. And like, oh, hold on, I can't get some of my designers to use that. They just want to know that they want a fluid radius that hits this. So one of the handbrakes for the growth of these technologies is the ease of access to being able to create 3D models. And we're hoping that things like the iPad and apps where it's more gesture-based might give us an easier way into making three-dimensional models. It's gradually getting easier, but equally you need to very quickly make it complicated as well. You need to create complex structures.
Would simple things like SketchUp be usable?
Google SketchUp.
Yeah.
I've got a couple of technicians that use Google SketchUp because
That's the simplest one.
a lot of the software that we tend to use tends to be expensive. So once the students leave the university, they can't afford to buy this software themselves. So we've deliberately introduced things like Rhino, which is a bit more accessible, but it's still quite a complex package to use. But SketchUp is definitely one that's easier. And then you've got things like Blender, which is good for organic shapes, which I think is free. And I'm hoping that things like the introduction of this Cubify 3D printer, they're now asking for people that write apps to help make a three-dimensional design tool that's app-based. And the reason we're not seeing too many that are app-based is that a lot of these softwares are too complex for that kind of platform at the moment.
You spoke a lot about benefits. What are the disbenefits? Are you limited by the size of the printer or the materials that you can use in the printing process?
Yes, there are a number of disbenefits. One of them would be the palette of materials that's open to you with a 3D printer. At the moment, you can use quite a number of plastics, ceramics, metals. You've got quite a nice choice. But it's certainly not as big as the traditional manufacturing environment and their access to a range of materials. The other disbenefit quite clearly is volume. These machines are excellent at producing 1 or 2 or 3 or 4 off. They're not very good at producing 50,000, 200,000 or X million off. The scale of economies that you would then go to tooling, you would then need to go to tooling. That's why the take-up of it in industry tends to be for bespoke applications. So racing car companies, they do use these technologies. Some car companies, BMW, Bentley, Rolls-Royce, they do use these technologies, but you won't find it in a Peugeot, you won't find it in a Vauxhall, not yet anyway. So the volume, scaling up is difficult, and size of components. Most of the machines I've shown you here are sort of this big to maybe this big, but they're not that big. That said, I know that there's one university prototyping a 3D printer that could produce components for the building industry. But that's a different level altogether, that one.
Are there any more questions?
As regards to the materials being used to produce these one-offs, can the same machine then cope with plastics and metals and various other ceramics and so on? Or do you have to have a range of different machines to do this?
At the moment, you would have to have a range of machines if you wanted to swap from a polymer to a metal to a ceramic. There are machines that will use different polymers. So there's an American machine, a Stratasys machine, the FDM machine. It uses an ABS material at one end and it can go right through up to a medical grade plastic or a food grade plastic or a polycarbonate, and it can use a range of colours and it can produce things that are virtually clear. Then you've also got the resin-based machines which can produce in different resins and flexibilities with different material properties. So you've got some flexibility within a single material type, but you can't migrate to a completely different material. At least I don't think you can.
So do you see over the sort of short-term future that the materials used in industry are going to start to get reduced down to suit the things that the prototypes can be made in, or will, when they tool up for mass production, they can go back to more traditional materials?
There's always a process of rationalisation, definitely, but they're trying to broaden the palette of materials, and they're trying to broaden the properties that these materials can deliver, and they're also trying to improve some of the colours and the finishes, and also translucent materials or virtual clear materials. There's been a lot of progress in that area. So it's the palette, its properties, what it can and can't do, it's developing. It will develop.
Yeah, I mean, one of the things we're trying to do today is talk about the case for better broadband in the area. Just wondering how data intensive the files you deal with are. I mean, can you collaborate easily online with them, and do you need a good broadband connection?
If you're dealing with 3D scanning, it's a pig, because the 3D scanner, even the one that we've got, which is quite a simple machine that deals in objects that are around about slow size, I can quickly generate a file that's 50 to 100 megabytes big. So to email that file to somebody is not possible, really. To pop it on a disk and stick it through stale mail, yeah, I could do that. But we tend to use cloud computing now. So we'll have Dropbox accounts, iCloud accounts, and we're sharing data that way. That's the easiest way for us to share that kind of data.
But you still need a pretty good broadband connection to do that.
Yes. Yes, you do. For downloading that data, good broadband speed, definitely. Good broadband speeds is very important, and also the other thing is very important is if you are restricted on the amount of information you can download per month, because with these technologies you will soon go over your limit very quickly.
Brilliant. Well, thank you, Mike, for that. That's fascinating. I'm sure that people come and visit you during the exhibition stage to finger some more of your objects and to find out more about the stuff that you do. What we've got now, chaps, is coming up will be the demonstration for 3D scanning. So we'll see about how we actually start to get some of these objects into the computer.